Was it a pictures man? Yeah. Oh, that's I guess so. Works really. Is this the very different. I'm sitting in office. Horrible. Whereas we've got house as well. Again, this is only assessed module at the moment. And are they clearly this is the worst that I'm feeling. And on top of that, he doesn't record his lecture. Yeah, oh yeah, exactly. It's horrible, Dave. It's not because this is, for instance, you want to use very issue with just the really big problems.
Yeah, you just duplicate. Okay. You just use duplicate, right? Yeah. Oh, stop. Yeah, just let me know if you need anything. Yeah.
And it's like a lot. Like when she plays
halfway, or do you just? I just get a design for things. Do you have like a natural like? Yes. When people can like come in. Is that around the halfway mark? That sounds quite early on. Oh, that's around halfway. Yeah, so halfway. These are like.
You don't have to worry. She's quite jealous. So yeah, so really it's so good by the goal is to win one the whole time. Yes, it's anything. Competing with probably the best. I think I see this. You know, I what do you mean? Of course, they'll be in between. Maybe they can basically anything wants to do. Then you're doing a 3D Oh, see, I don't have one issues to do that. I could not possibly do it in the use between the read extra tough or going to the public is much more. They're going to be free, whereas if I'm forced to do computing, it's like not read text outside. I would put it in the front.
Hello. Hi everyone, can I get your attention please? Can those that just came in just sit down? Yeah, settle down. So hi everyone, my name is Clemen. I'm the head of interdisciplinary modeling at ICDSS, and welcome to our advanced lecture series. Our lecture series focuses on the application of cloud technologies and learning how to deploy models that you have trained onto the cloud for inference, as well as generative AI. So it's a more applied track as compared to our other more machine learning focused track. But I think it focuses on stuff that it's not hard at school, but also stuff that is very important. So we're just going to dive deep into it. Today's lecture focuses on cloud architecture. We'll be talking about AWS, but it generalizes to all the other cloud providers because the concepts are the same. And we'll also talk about infrastructure as code, which is basically how you can just create your infrastructure in the cloud. Next week, we'll be focusing on data wrangling, and what it means is setting up pipelines to transform data from raw forms into more clean, structured forms for model training. Our lecture after that will focus on
on the calendar, it says that you booked 1:30. Are you using 1:30 or 1:39?
we have
Thank you. Sorry, interruptions.
our third lecture focuses on basically learning how you can deploy your model. For example, your trained decision tree or trained neural network onto the cloud. We also talk about containers, Dockerizing your models, and SageMaker. And our last lecture will focus on generative AI and large language models. So really interesting stuff. More about myself. My name is Clemen, and I do EIE. I'm currently year 3. I did an AWS certification, and I'm also an ex-intern at AWS. So if you want to learn about cloud or anything, I'm more than happy to answer your questions. Yeah. So before we start, we'll just have some simple icebreakers, for everybody to kind of know each other better. So if you could help me just take out your phone and just join the Mentimeter using the code above. And I'm not sure whether you guys have heard of this meme, but it's like Roman Empire. It's like some guys think of it every day, but it's kind of unexpected. So I just want to know what's your Roman Empire, I guess. And yeah. All right, food. It's kind of expensive nowadays. Roman Empire. Vintage race cars. Plus 42. Formula One. Not my degree. All right. Sleep. For those that just joined, we're just doing a quick icebreaker. You just join on mcmeter.com. Ease up. All right. Is sleep really necessary? Okay. Seems like pizza in everybody's mind. Don't worry, we'll be giving it up really soon. It's at the back, actually. Okay, just send me your final responses. For those at the back that can't find a seat, there are some empty seats around. You just squeeze in. Seems like sleep and pizza are the winners. So, okay, let's go. Okay, we're just gonna stop this right now. Yeah. All right, cool. Hi everyone. There's some empty seats around. You can just squeeze in. Okay, so let's just start proper. As we said, today we're discussing cloud architecture. And the first thing you kind of think of any like technology that you learn. Why is this so important? So nowadays, more and more companies are building their data architectures in the cloud. And when I talk about data architecture, this is what I mean. So this is a very generalized architecture of how any typical organization would process their data. On the left, you see like data comes in from different sources. Oh, whoops. It comes in from IoT devices, social media, even satellites for geospatial data. And all this raw data is kind of being put into something like a data lake. And afterwards, we transform this data into process data, which we can then use for different things like visualization, model training, and machine learning. Yeah. So what we're going to learn today is what makes an architecture in the cloud good, and also how to create these architectures using infrastructure as code. Infrastructure as code allows us to declaratively create the infrastructure, which will allow for a lot of good stuff like version control and rollback, which is quite useful. But we'll dive into that later. So what we want to learn today is how to design good architectures and how to make it. And to kind of dive deeper into the idea, we'll be looking at a simple e-commerce app like Amazon. So for those of you that have studied a bit of system design, this is how a general application structure is like. There's a front end. Front end is like your user interface. So for example, when you go to Amazon.com, the webpage that you see, the UI, and so on. And there's a back end, which basically has the glue logic that dictates, what happens, when you click that you want to buy something, for example. And there's the database, which is basically where you insert data and so on. Of course, there are different ways to deploy such an application. You could package it up, deploy it onto a virtual machine in an on-premises server. But that presents some problems. For example, when there's a new update, for example, in Linux, you need to manually go and reconfigure all your different services. That's very time consuming. Or if your application suddenly goes viral and your servers aren't able to take the load anymore. So as a server administrator, you're gonna have a rough time. Or even worse, there's a fire and your data center is now no longer operable. So the cloud comes in to kind of solve some of these problems, which we'll dive into soon. Just summarize why organizations are moving to the cloud. The first reason is that there's kind of some operational overhead when it comes to software updates and managing configurations. Also, when you don't deploy into the cloud and you manage your own on-premises infrastructure, you kind of have to manage your own security, high availability, and disaster recovery. What that basically means is, for example, just now when I said there's a fire, right? You know, make sure your services can hit a certain uptime, and you basically have to manage that yourself. And the last part is it's tough to scale on-premises infrastructure. So the key ideas that we think about when designing something using different services from the different cloud providers are generally these 5. Of course, everybody has their own say on what makes a good architecture, but I think this is a good general guide. The first is scalability, which is basically how can your architecture scale up to meet increased demand. You know, there are configurations that you can make in your architecture to allow it to automatically scale up in response to increased demand by tracking the number of requests, for example. The second idea is about reliability, which is basically what happens if something goes down. You might think, you know, the cloud is perfect, nothing can go wrong, but even the cloud providers have downtime sometimes, and you need to kind of like prepare yourself for that, which can come in the form of, for example, having multiple deployments in multiple regions. There's also the concept of backups. So if your database goes down for whatever reason, due to like somebody misconfiguring your database, what happens to your user data? Is it saved somewhere? And the next idea is security. And the cloud is not perfectly secure because the cloud provider is only responsible for managing the security of their data center. But you're the one configuring the network. And what that means is you're responsible for the security of your architecture. And people can still break in. If, for example, you leave configurations in plain text online, for example. There's also the concept of being DDoSed. So if people can send too much requests that it overwhelms your server and it goes down, we kind of need to prepare for that. The next concept is observability. And observability is basically saying, am I able to figure out if something goes wrong? Are there logs that basically tell me why my services are going down? And also, do I have metrics on how well my system is doing so that I can pursue some form of optimization or remove some bottlenecks? And you need to kind of like think about all these because these are all part of your configurations and design. And the last one is cost. So we need to think about how much we are paying for our different services. Some services are more expensive than others. Some are cheaper. And there are different ways to optimize an organization's architecture to basically decrease costs. So I'm going to just introduce some basic services in AWS. And we'll start with the most simple one, which is EC2. EC2 stands for Elastic Compute Cloud. And basically what that means is it's a very simple service that allows you to deploy virtual machines or instances into the cloud. And when I talked previously about scalability, something about EC2 is that you can basically configure auto scaling. And what that means is that we can automatically adjust the number of EC2 instances based on the traffic load. So previously I mentioned we can track, for example, number of requests, the rate of requests for services. And from there, we can automatically increase the number of instances that we've deployed allowing us to basically meet the demand of our application. And to dive deeper into what auto-scaling really means is beyond just one policy, there are also other policies that we can use to increase the amount of instances in the cloud. And another one is CPU utilization. So for example, if there is a deviation from the CPU utilization percentage, we can basically scale in or scale out, which basically means to increase or decrease the amount of instances to spread out the workload. The next concept to know is load balancing. And load balancing basically means to distribute incoming network requests across multiple servers. And there are different policies that enable load balancing. So a very logical, simple one is round robin. So let's say I have 3 servers. I can basically distribute the requests one at a time to each server. And that way I kind of spread out the workload for each server that I've deployed. Another concept to know is availability zone. So availability zone is basically an isolated data center within each region, and it allows us to accommodate high availability and fault tolerance, because we are able to deploy our services into different availability zones, and therefore, in case one goes down, we have others to back it up, so that our services still have uptime. And I know I'm kind of just throwing all these terms at you right now, but it'll all come together really soon. So just hang tight. So one more service that is quite important to know is you might have heard of databases like MySQL or Postgres. And AWS also has its own relational database service, or RDS, which is basically a fully managed database service. And using RDS, we are able to deploy database engines like MySQL and Postgres. And what this means is AWS essentially handles the patching, backups, and hardware provisioning. So same kind of concept where they handle some of the management overhead, and you just take care of like your core business functionality. So let's just put this all together in very simple architecture on how you deploy something like Amazon or any other web app into the cloud. This is what you would call a 3-tier architecture, where we have a web server, app server, and database. So as you can see over there, our architecture is decomposed into 2 different availability zones, and they're also configured to also have a load balancer. And our load balancer is able to spread service requests from one AZ to another AZ. And this achieves a few things. It allows us to basically meet demand because we have more services to handle it, and also allows us to introduce fault tolerance in case something goes down in one availability zone. So the key thing to note here is we want to analyze this architecture in terms of the 5 key ideas that I've mentioned previously. So the first one to look at is scalability, which is basically thinking about, what have I done to allow my architecture to scale up to increase demand. So as I said, we have load balancer, and we also have an auto scaling group. And this kind of allows us to take on some greater customer demand. But there are some things to think about, because no architecture is perfect, and there are areas that we can improve. First thing to think about is, for example, can our database handle an increased load? And is there more things that we can do to kind of meet increased demand on our database? We will not explain too much about it, but you can read up about ideas like sharding, like caching, that basically help to mitigate this. And also cold starts. So previously I've mentioned the idea of auto scaling, and something to think about auto scaling is how much time we need for application to start. So for example, if you've ever played around with Node.js or React or whatever, when you do npm start, it needs a few seconds to kind of like start up the server. And the same applies for any other virtual machine. there is a small delay that comes with basically starting up, and auto scaling does not really account for that delay. So there will be a bit of lag in between. So there are more things that we can adjust to optimize, but let's move on. The second idea is really about reliability. Basically, we kind of try to introduce that with the addition of 2 availability zones. And this protects us against a single AZ outage. But something to think about also is, do we have backups of our data in the event that our database goes down? So there are a lot of simple ways that we can do database backups in AWS. And one example is point-in-time recovery. And what that means is basically we back up our data at intervals in different every few hours, for example, in a day. This way we can easily revert back to our backup in case something goes wrong. The third idea to think about is security. So previously I mentioned about DDoS, and I also mentioned about how AWS and other cloud providers take care of security of the data center, but you need to take care of the network. So what that means is we need to be careful about our AWS account keys. How can we basically spread out the different roles and responsibilities of the different accounts in our organization to kind of mitigate that risk? And also for DDoS, one very common way to mitigate DDoS attacks is introduce something called a web application firewall, which basically helps to decrease and basically stop attackers from being able to DDoS your services. The fourth idea to think about is observability, which is basically, are we able to have metrics to tell if our architecture is able to handle the demand? And these metrics are something you need to manually configure and set up using services like CloudWatch or Datadog, and also our logs. For our web server or app server, if there's an error somewhere, we want to know what happened to it. And basically, we want to make sure there's also some form of log centralization. So all the logs should go into one central area that we can then afterwards do like some parsing or analysis to basically see what's happening in our setup. And the last idea is cost, which is basically how can we optimize our design to decrease the amount of cost that goes into our organization. So if you do an intern project, for example, a lot of them are due with how can we change our architecture to decrease our total cost of ownership. And one area that's quite easy, a quick win, is to change the EC2 instances that we're using. So EC2 instances have different kinds. There are spot instances, on-demand, and reserved. And they all have different amounts of costs. So as the name implies, on-demand instances are instances that you just use whenever you want. Spot instances are basically, you can think of them as instances that are just on a free market. So imagine a pool of instances, and there are some that are free. So we'll just take those. And reserved is, you keep a few for yourself. So the key difference, of course, other than cost, is also stability, because spot instances might not, last forever. And there are some downtime considerations that you need to think of. So if your application is critical, you might want to use reserved instances, for example. So now we've very quickly covered the basics of what makes a good architecture. And I would like to just emphasize that all of this applies regardless of the cloud provider they're using, and also applies to non-cloud setups, because these are concepts you need to think about when it comes to system design. So now we've learned kind of how to design something in the cloud. Now we'll learn how to make it. And when we learn how to make it, it means basically learning about infrastructure as code. But before I dive into what infrastructure as code means, I just want to share how you would configure something usually in the cloud. So this is the AWS console. I'm not sure how many of you have used it before, but typically you would go in and click around, to set up different EC2 instances, Lambda functions, and so on. There are a few problems with clicking in the cloud. if you think about it, imagine you're in a group of 4 for a group project. Everybody can just mess around. Somebody can misconfigure something, and we kind of have no way to tell what went wrong. And we can't roll back if we want to be in a previous iteration or state. And this entire idea of click ops is something we want to fix with infrastructure as code. So let's dive deep into what infrastructure as code, or IAC, is. And IAC is the idea of managing your infrastructure using code and automation. And we can basically use tools like Git to basically do some form of version control. So think of it this way: before I commit something to the cloud, which will change the state of my architecture, I can have my manager or my team member look at it. Or for example, if I need help with something, my team member can just come in, take a look at my infrastructure as code, and he can help me fix it, for example. And also promotes the idea of reproducibility, which is basically we are able to copy code from one machine to another, and there's no more problems of it works on my machine, because all of you are able to track the state of your architecture using the declarative code with IAC. And when we talk about IAC, there are a few frameworks that people usually use. You might have heard of Terraform. So Terraform is one of the major cloud providers. Very popular because you can use it across the different cloud providers. I consider it between Terraform and AWS CDK, which is I'll explain what it is soon. But basically Terraform is having some open source issues right now, so I will just teach CDK. Yeah. So what is CDK? CDK stands for Cloud Development Kit. And Cloud Development Kit allows us to convert familiar programming languages like Python to cloud infrastructure. And when this came out, it was kind of a huge thing, because previously people would use YAML or JSON, which aren't, it's not a programming language, by the way, to basically describe their infrastructure. And now CDK allows us to describe our infrastructure using familiar languages like Python or TypeScript. And why this is so good is because if you think about it this way, if your whole team is working in Python and you can also now have your infrastructure also be developed in Python, it's kind of a huge win, because now you just standardize to one programming language in the whole team. So this allows for very good development, faster development, and it also allows for improved abstraction with the idea of constructs and stacks, which I'll share more now. So CDK allows us to define constructs, which are basically, you can think of it as an abstracted form of your infrastructure. So later on, we'll be having a short demo where I'll share just a very simple example of CDK. Oops. And we are able to define all of this in a programming language and then synthesize it, which will then generate YAML, CloudFormation. So CloudFormation is the old form of IAC that was promoted in the past, which used YAML, which is very verbose. So CDK has basically taken over CloudFormation right now. And this allows us to describe AWS resources and configurations. So let's explain more about what a CDK construct is. So CDK constructs allow us to encode our configuration details, boilerplate, and glue logic for different services into one entity. And basically allows us to tap on predefined, prefabricated components. Later on, you'll see a very good example, which is, how can we easily combine Lambda functions and API gateway together, or really easily. Like building a house, why would you build the whole house from scratch? And you can prefabricate some of the components. And it allows these components to be highly customizable, shareable, and reusable. So there's the open source construct library as online, so you can easily take somebody's infrastructure and then easily bring it back and integrate it into your own architecture. So it makes development very fast. It also allows us to combine infrastructure together with runtime. As I said earlier, everything is united under a single programming language. So for example, if we think about it this way, I can have my React front-end user interface defined in TypeScript. I can also have my infrastructure defined in TypeScript and have them be combined in the same repository. And this is kind of amazing because everything is kind of united in the same repository. So it's kind of massive. Yeah. So our demo is very simple. We're going to set up a simple web service with AWS CDK in Python. And you don't have to follow. I'm just going to like show and basically describe the code base. We're going to keep things quick, so you can try it out at home if you want. But before we do that, we're going to talk about 3 very important AWS services. The 3 are API Gateway, Lambda, and DynamoDB. So we'll start with Lambda, and this kind of forms the basis of the serverless stack. So what serverless means is we can build and run applications without managing or provisioning our servers. And what this means is that we can write code like functions and just deploy it into the cloud, and AWS will take care of all the underlying infrastructure. So you can think of it as a even more abstracted form of computing, beyond just virtual machines, containers. Now we also have the functions layer. So Lambda allows us to achieve this abstraction, and it also allows us to run functions in response to events and basically respond to them. And it also automatically scales as needed. So several organizations have shifted their architectures to focus on a very Lambda serverless heavy architecture. This allows them to kind of decompose the different functions and basically easily scale up when needed. So some examples of how you would use Lambda as an analytics engineer, cloud engineer, or even machine learning engineer. Lambda can pull data from S3, which is a static data store, and we'll share more about what S3 is in the next week. Lambda can also pull data and move it into your database. You can also trigger different services like Glue, which is our ETL service or extract, transform, load, that we'll cover more in depth next week. Moving on from Lambda, we have DynamoDB. And DynamoDB is a serverless NoSQL database that automatically scales. What is NoSQL? NoSQL is basically a database that has no fixed schema. So data can be stored in various formats without a predefined data structure that you would typically find in a relational database. And also kind of encourages horizontal scalability because we can easily add more servers and nodes to our DB cluster. The last key service to think about is API Gateway, which allows us to easily deploy APIs onto the cloud. And these APIs can be in the form of REST. REST stands for representational state transfer, and it basically allows us to create, read, and update resources easily. You could deploy APIs using Express, for example, in Node. So with API Gateway, the API is highly scalable. You can easily implement rate limiting. You can also do monitoring to basically see metrics and logs. So it makes more sense to kind of put everything under API Gateway. So let's move on to a very simple demo. What we'll do is we're going to set this hit counter up. And my objective is to both demonstrate serverless and also demonstrate CDK. And the kind of objective of this hit counter is we'll send a request using curl to API Gateway, which will then trigger an API backend that is constructed in Lambda. This API backend will do several things. We'll first update an item in DynamoDB. Basically just adds 1, to an item. Very simple. It also triggers a Lambda function, which sends a simple response to your request, and then it forwards this response to you. And if you want to follow what I'm doing, there's this tiny URL over here that you can just key into your browser. It'll take you to a GitHub, and from there you can just see the code. If you're fast enough and you have already installed like AWS CLI, for example, you can even follow along. But if not, I would recommend you to take a look today, kind of understand what's happening, and go home and try it out. So before we move on, can I just get some help to distribute the pizza while you guys, look at the GitHub? Yeah, real quick. Yeah.
So the pizza now came a bit earlier because to get people, but
Yeah, I don't want you guys to eat cold pizza.
We're gonna
Yeah.
Yeah, so maybe yeah, we have pizza. Maybe we'll continue at like 7:30.
Yeah, please. You just pass through.
Alright, it is not the
My module is like one research paper. It'll just be one research paper. Exactly.
Yeah, I think it's pass through.
When the case are going through it.
One last question. You alright?
How many pizza do you buy?
Awesome. You got enough for the people that RSVP or not? What? Complain ah. I think eat lah.
I think eat also lah.
I think he's better. Elbow. Terrible. Oh, no, it's just
Who else is vegetarian? Vegetarian. Yeah, vegetarian. Can you come over here?
I think that's something to get more.
It's not. Yeah. Are you like sure? Yeah. We don't share with people for. Wait until the time. It says there.
They just like one.
It was like I mean, it's on the
Can I get one more slide?
okay, one plus at a time. Okay, you need to keep. No. As in, I'll order more.
No, you don't order.
I think not enough sense. Yeah, you guys.
I'm looking for
Yeah, I'm looking for my vegetarian. Wait, where do you put that?
Oh, you.
No.
Okay, I'll see. Oh.
This one. Yeah, sorry. The vegetarians they haven't gotten it yet, right?
What flavor do you buy? Or you don't like chicken? This is the problem. So, get what you do.
All right. While you guys are having your dinner, I guess, I'll just quickly go through the README on the GitHub. I've written here some quick description on what CDK is. So when you guys go home or something, you can just take a look. But the key thing I want to talk about now is the kind of commands that you would use to do what you want with CDK. And the first kind of command to know is bootstrapping. So how to bootstrap and what is bootstrapping? Bootstrapping, as it says over there, is the process of provisioning resources for AWS CDK to help you deploy your CDK apps. An example of what kind of resources it would deploy, I'm talking about stuff like S3 and different services that CDK needs to run in backend. So before you run anything with CDK, you need to run CDK Bootstrap. And later on, I'll be running Bootstrap for you guys to see. The next command is synthesis. And synthesis is the idea of basically converting your Python or TypeScript into CloudFormation YAML. And you can run this using CDK synth. And what this means is that it helps you pick out errors in your the code that you've written. The next command is CDK deploy, CDK destroy, and CDK watch. Names are kind of obvious for deploy and destroy. And the one I want to emphasize is CDK watch. So if you've used NodeMon before, NodeMon is basically something you use in Node.js and I think React to basically help you automatically update the state of your server whenever you change the configuration. And CDK watch does the same thing. It monitors for changes in your code and automatically updates the state of your infrastructure when a change is detected. Next command is CDK ls. So in a production grade CDK deployment, you would have different CDK stacks. Each stack is responsible for different things in your application. So for example, you could have one stack to set up a VPN. You could have another stack to manage the CI/CD pipeline, and so on. So right now we're only going to have a simple only one stack for our CDK deployment. But as I said, in a production grade deployment, you would have multiple. What we are building is a hit counter, and it has the architecture above over here, consisting of 2 Lambda functions, API gateway, and DynamoDB. So without further ado, let's delve into the code. So the entry point for any application that you deploy with CDK is app.py. Over here, you see that we have our CDK app, and we also have our single stack. So in a larger deployment, you would have multiple stacks, and they would all be deployed over here. The structure of CDK is kind of different between the different programming languages. I would say that most people use TypeScript for it, but to harmonize all our workshops, we'll be using Python. And we're going to explore more about what is in this stack. So just to follow the code, over here, we kind of go over to our stack, which is this. So earlier I've mentioned that we use CDK to describe our infrastructure. So I assume that for most of you, this is your first time seeing what infrastructure as code is. And it's quite logical. If I want to have a Lambda function, I just call the library for Lambda. And I basically write the different configuration details for my Lambda function. So over here, for example, I can define the Lambda runtime. In this case, we're using Python. So I'll write Python 3.7. And also mention that I want my code, I'll specify where my code is from. In this case, it's from the folder Lambda. And I'll also specify what my handler is called. We also have a construct over here. So earlier, I also emphasized that CDK promotes the idea of abstraction. And what it means, it allows for prefabricated components. So if I want to combine Lambda and API gateway, which is an extremely common pattern that we see. We can just simply type Lambda REST API from the API gateway library in CDK. And of course, everything is a library that we import from AWS CDK. And I just want to dive deeper into the idea of patterns. So as computer scientists, we want to adopt a do not repeat yourself principle. So whenever there's a pattern and there is some form of abstraction that we can exploit to bring off some kind of efficiency, we want to use it. And there's this very useful website called CDK Patterns, which basically describes the different kind of patterns that organizations use in their architectures. So there are many. I will just click Lambda function, and you can just take a look at the different patterns that people have created just to follow. There's also the construct library, and you can search that to basically import people's constructs into your code base. So that's not to say that you as an engineer, all you're doing is just importing libraries. There's kind of a lot of gluing and tweaking that goes into it. One problem that I face is that a lot of the code that's written out there is kind of outdated. So you kind of need to change it to work. So back to the code. Let's explore how a Lambda function is written. And I assume that for most of you, you've never written a Lambda function before. Let's go into a simple one. So this is kind of the back-end downstream Lambda that I've pointed out previously. Over here is this one. There's a Lambda that basically does the function of sending back a response to your request. Very simple kind of diagnostic function. All it does is basically takes in, when it's triggered, it will just send back a response, and we'll see this response in our command line later. Let's go into this hit counter over here. So in this construct, I've kind of defined several important things. The first is my DynamoDB table, and I've kind of defined it very simply over here. For those of you that are new to Python, I've kind of written some commands to help you if it's your first time seeing some of this code. And here in DynamoDB, like Lambda, I just write the different configuration details that I have. In this case, I indicate my partition key to be path. Sorry, path. Then I also define another Lambda function, which will serve the role of this API backend. So something interesting is this environment configuration. What it means is that I can basically pass in different values into the Lambda function code. And you can just use this as an environment variable in your Lambda function. And something I've kind of never grasped at the start was the idea of late bound values, is that some values are only defined as deployment, at deployment. So for example, what our function name is or what our table name is kind of only defined when we run CDK deploy. So if I want to do that, I just simply call a function name or table name from the object over here. So one other thing that you also kind of need to think about is permissions. So earlier I've mentioned the idea of security, that we want to kind of control what permissions we have in our architecture. And the way to do that is through a service called IAM. And IAM stands for Identity and Access Management. And using IAM, we're able to define different permissions, different roles for the different parts of our architecture or the different users. In this case, Lambda functions also have a role. And for our Lambda function, we're given the role to read and write to our database. We just need to indicate that declaratively in our CDK code. So over here, I've written table.grant read write data. And what it means, it just gives permission to read and write to our Lambda function. So let's go into this Lambda function, which basically serves the main core of our service, which is to run an update on our DynamoDB table. So this application, basically when you curl it, curl means to send a request to, it basically updates an item in DynamoDB table and just adds one to it. Really simple. It also invokes the downstream Lambda, which will then return a payload that basically just sends a response that says, oh, hello, just to say like, oh, it works. Then subsequently, I just return the response, and if I'm the one curling, I'll see it in my command line. So that's pretty much it. You've kind of understood the idea of having constructs, having stacks. So let's go into how the CDK command line works. So I just open my command line. So the first thing you do after you like create your code and everything, and you just want to deploy, so run CDK Bootstrap. So I've run CDK Bootstrap previously, so it might not do anything, but yeah, it's probably bouncing out because I ran it previously. So let's assume that you've already ran it. The next thing you can do is CDK synth. And what CDK synth does is it allows you to kind of synthesize all your Python code into YAML. So as you can see over here, the Python code has been compiled down into YAML, CloudFormation, which AWS can then use to deploy your code into the cloud. So synth works. Let's run CDK deploy. Now I run CDK deploy, and it'll take some time. For very large deployments, it'll take maybe even 5 minutes, 6 minutes. But this is a very simple one, so it'll just take a few seconds. So it'll basically tell you like, oh, these are all the key policy changes. You just want to take a look at the summary, and it's okay. You just deploy, and it will basically deploy your CloudFormation code into the cloud. And yeah, it'll take some time, but it will be done in a few seconds. So it says here resource creation initiated. So it's basically creating, like it's in progress. And afterwards, if you log into the AWS console, you'll see that this has been created. So I'll just log into the AWS console right now to just help you see. So give me a second. In the meantime, you can just take a look at the GitHub and take a look at the code. All right, so I've logged into the AWS console. So I've just gonna jump over to DynamoDB. So this is the DynamoDB dashboard. If I just look at the tables, I'll see that my table has been deployed. So this one over here. So we know that our deployment works. And something I just want to bring your attention to, and I think it's useful, is to look at the CloudFormation console. So CloudFormation is the old way of writing code declaratively in the cloud. And if you see our CloudFormation console, there is a stack that we've deployed just now using CDK deploy. So our infrastructure has been deployed. If we take a look at API gateway, you'll see that an API has also been deployed in a moment. So over here, the endpoint. So yes, our API has also been deployed. So things look right. They are deployed in the cloud, and we can see it in our console. So let's just do a very simple sanity check with the curl. So I'll need to find the execution API URL. That'll take me some time. Give me a moment. Okay, anyways, the API URL is hidden somewhere inside. If you try yourself, you'll find it. This is why people don't like the AWS console, because it's hard to find stuff. But yeah. So anyways, if I would have curled the URL, the execution API URL, I would have gotten a response. And from there, I would have known it works. So if I just want to show a bit more of the console, if I were to go DynamoDB, I can just see my table. I can see the items. Whoops. And over here, you would be able to see, like, the different items that are present in the table. So export table items. And yeah, if I run curl on the URL, it would have shown. So yeah, I guess that's pretty much it. If you want to learn more about CDK, I would just recommend checking out the patterns. This hit counter thing was inspired by the CDK workshop. So just search CDK workshop. You would be able to find the intro CDK workshop, which also has different programming languages. Yeah. So today we did Python, but most people actually use TypeScript. So I would recommend checking out TypeScript as well. And if you just want to learn more about AWS, I would recommend looking at the different certifications that are out there. I think it's a useful way to get into the different services that are available. If not, that's it for this week. Next week, we'll be having a deep dive into data wrangling. And that means setting up, S3, AWS Glue, and also an introduction to data warehousing with Amazon Redshift. So no, that's all. Thanks so much for coming. Have a good day.
Yeah.